focus on the radical part of it. So let's tackle the rad 800.
400 too.
Yeah, rad 400 and rad 2.
It's so rad.
Totally. 400 is a perfect square, yeah.
Can't you do 108?
You can, but then you got to break down the 8. Because 8 is a product of 4 and 2, and 4 is perfect. So you could, any avenue is going to get you to the right answer. You just have to sometimes go a couple extra steps to get there.
I didn't know that was for
And that'll happen often.
You could do 801 when you're 8 whatever. You could do it.
Right. So bring down the 6 and then multiply the 6 by the 20 because only rational numbers could be multiplied together. You can't multiply a rational by an irrational. 120 times the root of 2.
Would you like multiply by the reciprocal? For the
You can. There's actually a couple of approaches.
like,
I'm
could
going
you
to show it.
multiply by radical 725?
That'll make it more complicated. Just the radical 7 actually. I'll show you this. But
Oh
let me,
yeah, that's true.
let me just talk to you about a couple of things real quick, just as a refresher. Well, in a second you'll see where I left off on because if you don't know your powers of 2, we talked about this, you could just type in x squared, all right? So y equals x squared, go to the table, and then everything in your y column would be a perfect square. Everything in the x column is the square root of that perfect square. So for example, 49 is a perfect square, 7 is the square root of that, all right? So eventually you get to 400, all right? You see that that's a perfect square. Now, the other thing that you could do, which may be more useful because if you already know your perfect squares, if you have a sense of the perfect squares, even as high as the 400, which is 20 squared, you can look at 800 the way we did in an x chart and just do 800 over x to see what its factors are. And then just go down your list. Well, let me get back to the top here. Go down your list looking for at least one perfect square factor. So 1 in 800, neither of those are perfect squares. If you're in doubt, maybe you think 800 is a perfect square. Type it in your calculator and take the square root. So square root of 800 gives you a decimal, not a perfect square. Then you look at 2 and 400, and pretty much off the bat you get it. So you know your perfect square is 400, and the other factor would then be 2. All right? It's possible you may have missed that one. You get 4 and 200. That would work, but then you got to break the 200 down. All right, so it becomes multi-step at that point. 8 and 100, same deal. 100 is a perfect square. 8 can be broken down. So as long as you don't just assume that the choices you made are the perfect choices off the bat, you'll always be on guard for maybe a follow-up step or two. That's really the key ingredient. It's the same idea with factoring, where you think to yourself, and you should have been thinking to yourself, is there any more that I can do? Is there another factoring technique? You know the directions that say factor completely. Can I factor a difference of squares? Can I take out a GCF? Things like that. Here it's more like I'm looking at that radical 2. Can I break that down further? If the answer is no, then you're done. All right. So let's take a look at number 1, which is a little extension of it. This process is called rationalizing. All right, we're going to learn particularly how to rationalize the denominator, but the idea is to know how to rationalize in general. Rationalizing is really, you can just read the blurb, but it's just telling us that we're taking a fraction and simplifying it as far as we can in such a way that if there is a radical, it's only in one part of the fraction, right? Either on the top only or on the bottom only. generally the skill has us focusing on trying to get radicals out of the bottom of a fraction, because if they're in the top of a fraction, it's generally not a problem. On the bottom, it could make the computation a little bit more complicated, right? But before we even get into that, I can use a little nifty technique, which isn't really a technique, it's more just like how numbers work. The square root of a fraction is a fraction of the square roots, aka I could split it up. Square root of 25,
5.
yeah, because it's perfect. So we have the 5 over rad 7. All right, so I want to get the rad 7 out of the bottom of the fraction.
Wait, but I thought you can have a radical multiply.
Yeah, that's the idea, but sometimes we want to get it out of the denominator. All right, so we're going to practice. This is really, the skill is practicing getting the radical out of the bottom of a fraction. All right. You'll find, different sources, resources online, textbook, whatever, the one that you don't have. They say that you can't have a radical in the bottom of a fraction. That's not true. It's just moving forward, pre-calc, calculus, more complicated courses. It's a skill that will benefit you, all right? Most often, if you have a fraction where there's a radical in the bottom, by using this technique called rationalizing, it'll allow you to come up with a simpler answer, all right? So you're just learning a skill at this point. What I want to do is I want to get rid of that radical, all right? I can't just square a fraction. If I could, that would make the radical go away, but then I would have changed the value. So if I had something like 1/2, could I just square it? It would make it 1/4. Is 1/4 the same as 1/2? No, I changed the value of it completely. They're not equal. So I can't just square a fraction.
So you're making it like 2/4?
Making it...
Well, like in that example.
Right, yeah, so we'd have to do something equivalent to making it 2/4, which would be multiplying top and bottom by 2. So that's a good point. Multiply top, if I wanted to make it something equivalent, I could multiply top and bottom by 2. Here I'd multiply top and bottom by what?
7.
The rad 7. At least we'll know we're getting an equivalent fraction, right? It's going to be the same value. And when you multiply by a number over itself, that's the same as multiplying by 1. Anything over itself divides to 1. So whatever numerical value this is as a result, it's going to be the same as what we started with. Right? If I typed in this operation into my calculator, I would get a decimal. If I compare that to the original fraction in the calculator, I would get the same decimal. So we have not changed the value. But we're going to change the look of it. Because 5 times root 7 is 5 root 7. What's root 7 times root 7? 7. Exactamundo.
Wait, why?
That's our final answer, yeah.
Oh, because 49, it's like root 49 and then you go to 7.
Exactly. So root 7 times root 7 is root 49.
But I thought you can multiply.
You can multiply if they're both radicals, yeah. If they're the same type of number.
But isn't there still a radical in the front? How is that?
How is this any
Now
better?
it's on the
Yeah.
numerator.
No idea.
So why would you do that?
Honestly, once you get to like pre-calc and calculus, I'm gonna be like, forget about this rationalizing nonsense. This is a nicer answer. But for some algebraic processes, when you get to imaginary numbers, that's algebra 2. This concept is going to be really useful. It's going to take something that doesn't look like it'll simplify and make it simplify really nicely. So we're just playing the long game at this point, though. All right, now for this one, I could break it up. I could make it rad 5 over rad 15, but why not?
Rad 1 over 3.
Yeah, rad 1 over 3. Simplify it first, then break it up. Rad 1 over rad 3. Rad 1 is?
1.
So 1 over rad 3. All right?
That's the answer?
Unfortunately.
Oh, I don't know why it's disappointing.
I mean, it's crazy because this is nice. It's
Simple.
neat. It's a good looking answer. And we're about to make it not look as good, but there will be a reason
Rad
for
3
it.
over 3.
Rad 3 over rad 3. So top is 1 times rad 3 is rad 3. Bottom is rad 3 times rad 3, which is rad 9, which is 3.
Oh, so you can get rid of the 1 and just keep it right.
Yep, because the 1 times rad 3.
But you can't multiply non-radicals by rest.
Well, that's the thing. 1 is one of the, it's like the exception to just about every rule, because 1 is the same as rad 1. So I can actually multiply. Or I could even think of this as 1 rad 3, but then the 1 as a coefficient would disappear. So, just a quick check. Square root 5/15
Oh,
square
there's our
root
answer.
of 3 over 3.
Shoot, how do you get the fractions going again?
Like the
Yep,
fraction
alpha
law.
y equals.
Thank you.
Enter. No, but you have to, delete the 5.
So,
You have to do that before you start it.
at least we know it's right. Unfortunately, your calculators don't have a math rad key. They have a math frac key, but they don't have a math rad key. So it's never going to take a decimal and put it back into a radical form for you. So there's no function that'll do all this for you. All right, so most of the time, in just about every other lesson, it was, let me show you how to do it by hand, and now if you have a multiple choice question, you do it on a calculator like this. This is the exception to that. There really is no way to do it, because if a question asks you for an answer in rationalized form, I mean, you can make sure decimals are equivalent, but if you don't know what rationalizing a denominator looks like, what the final answer ought to look like, then there's really nothing that you can do about it. All right? So, shocking. Number 3.
Wait, so if you got like the rad 3 over 3, if the rad 3 was something that could be broken up, would you break it up?
You'd have to break it up further. Yeah.
Looking at number 5, and I thought it was really easy, and I'm thinking that it has it.
So the missing ingredient is number 3, because this is the one where there's more than one item on the bottom of the fraction. So this, first off, take a look at the numbers on the outside. Is there anything you can do with those? The 3 and the 2, can you simplify those?
No.
Okay. Is there any way you can simplify the rad 5 and the rad 2?
No.
No, they're both prime numbers. You're not going to do anything there. So I need to rationalize. I need to multiply top and bottom by something. What is that something? I think I heard it.
Ooh.
Rad 2. All right, so you're only multiplying top and bottom by the troublemaker, by the thing that you don't want to have. Because the 2 on the outside is fine. The rad 2 is the problem. So rationalize that. What's that?
Oh, you can, alright,
He answered, all right.
Very good.
You're going to make me obsolete. As long as I keep getting a check, I guess. So 3 rad 10, because the 5 times the 2, right? Because they're both radical, so you can multiply them. And then it would be all over what? 4, right?
So 2.
Because the rad 2,
4 times 2.
the rad 2 by the rad 2, you did 2, but the 2 that was already there.
Yes.
Now, these simple operations, if it gives you an answer that's non-radical, your calculator can handle it. Like, if you type in 2 radical 2 times radical 2, it'll tell you 4. The problem is, if you type in something like 3 radical 5 times radical 2, it's going to give you hideous decimal. That's what meant, right? So, at that point, you'd be stuck having to do that part by hand. But you can let the calculator do some of the work for you. It's just not going to, it's not like one-stop shopping like some of the other things that we've worked on.